All right, today we're going to take another look at the maclaurin series, and we're doing a maclaurin series for e to the x. This is actually number 1 on the handout that's listed there on Canvas. And what I did is I went ahead and wrote down the derivatives. Derivative never changes. It asked me for the first 5 terms, so I went to the 4th derivative. Each value at 0 is 1. The nice thing about the video, you can pause the video to get that down. It's just nice to write it all down ahead of time because it makes the video a little bit shorter. When I go through and write the maclaurin polynomial, e to the x would be 1 plus 1x plus 1x squared over 2 factorial plus 1x cubed over 3 factorial plus 1x to the 4th over 4 factorial. Now, of course, I don't need the 1's there, but it helps you see where these values were coming from. Those were the coefficients. The power matched the factorial, so 4 factorial, 3 factorial. Even if I came back to these, we talked about them being 0 factorial and 1 factorial. Now on that same handout, down at the bottom, number 1, is to find the maclaurin polynomial for e to the negative x squared. This is typically what's asked on an AP test, something a lot more difficult as far as the derivatives. So if I took the first derivative of this, it would be e to the negative x squared times negative 2x, and then after that you would have a product rule for each one going forward, which makes the derivative a lot more difficult. So if you're asked to do something like this, don't go back, do the basic one, find whatever this is. Then you can actually take negative x squared and substitute it for every x value, and you'll have your maclaurin polynomial. So a lot less work doing the base one. So I would have 1 minus x squared plus negative x squared over 2 factorial plus negative x squared cubed over 3 factorial plus negative x squared to the 4th over 4 factorial. That's the raw form, that's fine, but still simplified out would be 1 minus x squared square root negative plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial, and then plus x to the 8th over 4 factorial. Again, that's fine. You can work the factorials out. That doesn't matter. But this is a quicker method because the derivatives are a pain because of the chain rule here than it is to do the base one. So you do the base first and then go into that next one. Now we'll take a look at another one, similar type situation. All right, now I have the information up here for the cosine x. And on your paper, it asks you to do the first 5 terms. So this time I had to go past the 4th derivative. I actually went to the 8th. And that's simply because of all the zeros that are filtering in. So when it's saying first 5 terms, it means first 5 non-zero terms. Okay, so sometimes, especially on these alternating functions, you've got to go a little bit further. So again, if you need to, pause the video, get this information down. You have all the pieces here. And now we'll start to write out this maclaurin polynomial or maclaurin series for cosine. So I would have 1 minus 1 x squared over 2 factorial. We skipped the x one, went to the x squared. I can remember it's the x squared and the 2 factorial because it's the second derivative. Now we're going to the 4th. Plus 1 x to the 4th over 4 factorial. Then minus 1 x to the 6th over 6 factorial. And then plus 1 x to the 8th over 8 factorial. There's my first 5 non-zero terms. And this is what we kind of worked with in the past. Here comes the new one. On that handout, this would be number 2 down at the bottom. The AP test would want me to find something like the maclaurin polynomial or series for cosine square root x instead of x. The derivative of this would be negative sine root x times 1/2 x to the negative 1/2, and then product rules going forward. which is an awful lot of work if you're going to 8 derivatives. So, if you're asked to find something like this on an AP test, don't do it. Go do the base one. Go find that base one. Derivatives are much easier, getting those values. Then find this guy, because all you have to do is replace root x in for every x. So if I write it out, replacing square root x for every x, 1 minus square root x squared over 2 factorial plus square root x to the 4th over 4 factorial minus square root x to the 6th over 6 factorial plus square root x to the 8th over 8 factorial. Raw form, simplified out, would be 1 minus x over 2 factorial plus x squared over 4 factorial minus x cubed over 6 factorial plus x to the 4th over 8 factorial. So in other words, very quick to get this guy using our base form. Otherwise, we're going to have a lot of trouble going through all these derivatives. Go to that base form. There's 2 more on that worksheet that I want you to work out. One is for the natural log of 1 plus x, and the other one is sine x alternating. And then you're going to find the more complicated one by substitution. Find the base one first. The very next one being ln 1 plus x. Derivative would be 1 over 1 plus x. Again, think of that as 1 plus x to the negative 1. In this case, the chain rule is always going to be 1, so it's not going to be too bad. F double prime of x, negative 1 plus x, negative 2. F triple prime of x, 2, 1 plus x, negative 3. 4th x, negative 6, 1 plus x to the negative 4. And then when you're finding all the maclaurin values, so they're centered at 0, f of 0 would be 0. The natural log of 1 is 0. F prime of 0 would be 1. F double prime of 0 would be negative 1. F triple prime of 0 would be 2. And F fourth at 0 would be negative 6, giving me those coefficients, because each one of those are going to give me 1s. And you can write out that polynomial, and then you can do the one below where you're going to replace x squared for x. That was our only difference there. And then the sine one, you'll have to go through more derivatives like we did on the cosine, but go through number 3 and 4 at the top, and then number 3 and 4 at the bottom.